Hello from IP SoC 26 in Silicon Valley. I have to be with an old friend, which is Ali Khan. He has a company which is called Correva. So Ali, they are not an IP provider, but they provide a very important service to the IP vendor. They're offering a prototyping engine, which is quite not big, that they can put on their desk, and they can map their FPGA on Xilinx, and then they can run their simulation. So I think it's an important service for the IP provider to quickly test their IP. So please, can you comment what is original, what's good, what's the best?
Thank you, Gabrielle. It's good to be back at Design and Reuse. My name is Ali Khan. I'm one of the co-founders of Correva. The company is a new company, but the team that has been that started this has been doing this for over 3 decades. They started at a company a long time ago called QuickTurn that was acquired by one of the major EDA companies. And then they started another company or were part of another startup that got acquired by another major EDA company. And now this is their third life. So they understand the prototyping and emulation world, the hardware-based platforms that are necessary for the requirements of the customers today. And so we have a complete software stack solution for FPGA-based prototyping that allows for customers to do validation work on starting from the smallest IP cores with subsystems, going on to complete SoCs, multi-billion gate SoCs. They can be partitioned with our software stack. One of the greatest values we offer is that we actually allow for the adaptation of our software stack to the customer's environments. So being a smaller and newer company, we are much more flexible and can work with customization and adaptation into the workflows of our customers. We have managed to work with the largest of the companies in the valley which are using our products today. And the company is based in Santa Clara, California, right here, 100% US owned. And the topic for our presentation today is going to be desktop prototyping, so enabling engineers to validate their IP on their desktop so they don't have to be in the queue with others waiting for resources to be available. They can iterate very quickly on their versions of IP, whether it's an AI level IP core or RISC-V processor core. They can do that very rapidly, and basically this is enabling them to faster time to market, and that's the value we offer today.
So prototyping is not a new story. So what's really new? The cost of the compaction of this engine, because everybody can have it at this desk, or is it also what is around? Or if you prefer, and also the question is, what are the type of IP or a circuit that are not very easy to prototype? So the first question is this is a very engine, you say very practical on the desktop, and you say for IP provider, but in fact for any design. What are the limits? You could say, I have a very compact engine, but some circuits, when they need memory or special blocks, then I cannot. What are the limit, would you say? Don't use this because it's, I don't know what, too complicated?
Right, so the solution we are pointing to here is one FPGA card. The card has memory on it. We also have a system, and one FPGA system, which is based on the next generation of the Xilinx FPGA. This one is based on the VU19P. The system is based on VP1902, the largest, so it goes from 50 million to 100 million gates. If the IP requirements are in those size requirements, these are very good solutions. The limitation is not at the bottom. I mean, if you look at how large the SoC can be, we have platforms that actually allow scaling from current platform with the same software, what's running on this one FPGA system, all the way up to 32 FPGAs or 6 FPGA system that's cascaded into a large number of FPGA arrays. So the question you were asking, what is new, is basically we provide not only the hardware and the software that goes with the system, but we also enable our customers with the software that can be ported onto their own hardware platforms. That's something that we provide, which is not traditionally offered by other vendors. And then as far as limitations, I think we're finding that AI requires a lot of adaptability and flexibility in the way it's being tested. And so we are also working with our customers in order to make sure we are able to adapt to what they're looking for. We're being a smaller company, we're much more nimble and flexible in doing that.
Maybe I'm too critical, but you can certainly validate functionality in a functional way, your IP and your circuit. But if it goes to advanced node, you cannot really verify some timing aspect because your FPGA has not the same timing. So I think it's a step of validation, but it has limits in terms of verifying critical paths or whatever. You agree with this?
Yes, there have to be, in order to do a proper, mimicking of the design, you have to be able to have the same level of timing. So we work with the timing parameters, clock frequencies. The partitioner, one of the greatest experienced people, or our strengths are in that particular area, which has to do with managing clock frequencies across partitions. But those are challenges, absolutely, as you point out correctly. Yes.
Anyway, you can have a very good level of verification and still let some of the issue. You cannot solve everything. Okay, anyway, I think everybody will be happy to see that such a board is available, and look, they can read your talk and come back to you.
Thank you very much.
Thank you.